Today we're going to focus on area, which can be a little bit trickier to understand than perimeter. So area is in layman's terms, the amount of space inside of a figure. So technically it's measured in square units. So how many squares can I fit across a space? So the squares could be in inches, feet, meters, units in general. For the first example, we're talking about centimeters. So the most basic example we can look at is a rectangle or any kind of square. It's just going to be the base times the height for the formula of area. So area is two-dimensional. So when I multiply those dimensions together, that's where I get, in this case, 5 times 8 is 40 centimeters squared. So that's typically how we write it. Technically, any parallelogram we can think of as just the base times the height. Even this typical traditional parallelogram with that slant, as long as the base and the height are perpendicular, you can still use this key formula of base times height. And again, base and height are perpendicular. They're underlining that. They're using exclamation point. Keep that in mind. That formula is still in play. Triangle is just 1/2 times base times height. Again, you can think of it as just base times height divided by 2. As long as the base and the height are perpendicular, you're good to go. So that's the really key piece here. So with this second example, they're giving you an isosceles triangle. And they said, okay, well, each leg is 22 feet and the base is 16 feet. Can I just say 1/2, using that formula, the base of 22 or the base of 16, either way, times the other dimension, 22. Why can't I use that? The issue is 22, whether you choose this length or this length, is not perpendicular with the base of 16. Isosceles triangle though, things work out nicely. I can drop an altitude, so I'll do that. So when I drop this altitude, okay, that's perpendicular. Some students think of it, okay, now I have two triangles. Sure, so what I want you to focus on is just one of them. I chose to focus on this triangle with the 22, and because it's isosceles, that 16 just was split in half by the altitude. So if I can find this height, I put X for height, you can use H for height, I'll have the pieces I need for my area of my triangle. So with a quick Pythagorean theorem over here, and I didn't round too soon, I got 20.494 for the height. I now can go through and find the area of the triangle. I want to be clear about what pieces you need to use though. So common mistake is to use that 8, but be careful, the base is this entire length of 16. So I put that in it for my base. It doesn't matter which order you put these in. And again, I found the height, which is perpendicular, to be 20.494. I multiply those together and divide it by half, or multiply it by half from the very beginning. Either way, when you round, it's going to be 164. And again, area is two-dimensional. So in this case, it'd be feet squared. So let's go to the next example. Oh, sorry, continuation. So we're saying that's a patio. We're covering it with stone. So for every square foot, this is how I would read this, it costs you $12.25. So intuitively, some people would think about it as 164. This is feet squared. So if I multiply that with the $12.25, that will be my answer. Another way to look at it is do a unit analysis. So 164 feet squared, if I multiply by 12.25, and that's dollars, per means divided by, and it says square feet. Well, that means per every 1 square foot. The feet squared cancel. One's divided by the other. So I'm definitely left with money. And again, more to come, we'll do a more formal lesson on unit analysis. It's either going to be multiplication or division. When you multiply, yeah, that makes more sense in this case. So going to the back of your worksheet, we're going to now work on a coordinate grid. So they gave us a parallelogram. I graphed that for you. And, sorry, they gave you 3 vertices. They gave you A, B, C. We need to find D. Again, a parallelogram, opposite sides are parallel, so same slope. Opposite sides are congruent, same length. So I kept it in the correct order. So I went A, B, C, D must be over here. So I just did that by staying parallel to this horizontal side and counting out the same number of units. It happened to be 9. And then it says determine the area. 2 ways that I can think of right off the bat to do this. The first way, which I didn't write down, would be to put a rectangle. If some students like to look at this visual, put a rectangle around the figure and find the area of that. And then these 2 triangles here, I could find the area of those 2 and subtract them out. However, because a parallelogram still employs that base times height idea, the quicker way to do it would be to choose a base, so choose one side. So I chose D to C, and make sure you find a height that's perpendicular to that spans across the figure. So it needs to go for, this is like the top, this is the bottom, make sure it goes from one vertex down and is perpendicular to the base. That would get you the right answer too, and that would be a quicker method. So you end up having 72, and in this case we don't know what the units are, so we say units squared for the area. Okay, looking at our last example, another isosceles triangle, so we're really pushing this. They want the area of the triangle, so I like to start all my measurement problems writing out my formula. Area is 1/2 base times height. I don't know the base, and I don't know the height. Okay, fine, take our time with it. So I do know the legs are each 10, and this 46 degrees is the vertex angle. With any of these problems, I need that perpendicular piece. So I started off with that. I said, you know what, I'm going to put an altitude here. It's isosceles. Things work out really nicely. Yeah, those are right angles. This 46 got split in half, so those are each 23. So ignore this 3.907 for a second. What I have here is I have 23, I have a 10. I chose to find this first. That's fine. So I said that was X. You could have chose to find this other side first. So because I have an angle of 23, I have one side length, I have to use trigonometry, can't use Pythagorean theorem, I could use the opposite side of X. So that's where I got sine from, because I'm also using the hypotenuse. So sine of 23 equals X over 10, opposite over hypotenuse again. And if you wanted to, you could put this over 1. And then when we cross multiply, I just multiply the 10 and sine 23 equals X. I didn't round to the nearest square inch yet, to the nearest inch, excuse me. So I just kept in my calculator or wrote down 3 decimal places or 2 decimal places would have been sufficient too. I need to be clear though that this is just part of my base. So I wrote down that if I doubled that number, my entire base would be 7.815. To find the height, I could have used trigonometry again. If I used trigonometry, I probably would have used cosine, because I would have used this adjacent side in the hypotenuse again. You could have also used tangent with this opposite side of 3.907 and this adjacent side. I chose to use the Pythagorean theorem again, so Pythagorean theorem, or I even wrote down the cosine piece for you. Either way, this is your height, 9.205. This got cut off, unfortunately, but all I did, I'll kind of scroll down here. Oh, can't move any further. All I did is 1/2. I'll write it down up here. So 1/2, the base. So I'll put area equals 1/2. The base was 7.815. And then the height happened to be the 9.205. There's a lot of numbers here, so that's why I like to label things as I go. And if you round that to the nearest square inch, I'll give the answer to you. I believe, I gotta look at my packet here. It's 36, yep. So I'll say it's 36, round to the nearest square inch, inches squared. So number one thing with area, you're going to have access to the formulas. Look for perpendicular base and height. So that's my lesson for today. Have a good one.